In this video, I'm going to introduce you to cryptography, some concepts and terminology. Cryptography is all about disguising data, or secret writing, so to speak. And it's the most commonly used tool, the strongest tool used against the main security threats. Good enough cryptography tools will make the data impossible to read, modify, or fabricate. The concept of cryptography is rooted in higher mathematics, such as number theory, which studies the properties of whole numbers, group theory, studying the algebraic structures known as groups, obviously probability and statistics, but fortunately for everyone, it's not necessary to understand the underlying mathematics, just like you don't have to understand how a combustion engine works before you can learn to drive. The concept of encryption is basically translation between original form and the scrambled form. Encrypting is the process of obscuring the data. Decrypting is getting the data back from that obscurity. We sometimes also use encoding, decoding, and cipher and decipher. But the overall system is referred to crypto system, the system that encompasses the whole process of encrypting and decrypting. So, plain text is the term for the original form of the data. Ciphertext is the encrypted form, and the encryption is the translation between them. So you see, you start out with plain text encrypted, send it as ciphertext, then decrypt it, and the receiver can read the original plain text. The terminology is adopted from sending and receiving data as messages. And we talk about messages. We talk about the sender S and the recipient R, and T, the transmission medium. We can think of T, the transmission medium, as sort of like the post office. The sender and recipient don't have to be humans. They might be just programs or even just classes within a program. But we talk about the outsider, or O in this instance, as the interceptor or intruder. In this chain of S to R through T, anytime after S transmits the message via T, the message is vulnerable to exploitation. And O might try to access the message in any of the following ways. Block it by preventing it reaching R, thereby affecting the availability of the message. Intercept it by reading or listening to the message, thereby affecting the confidentiality of the message. Modify it by seizing the message and changing it in some way, affecting the message integrity. Fabricate an authentic looking message, arranging for it to be delivered as if it came from S. You probably know that as spam messages often, thereby also affecting the integrity of the message. As you can see, message vulnerabilities reflect the 4 possible security threats we identified in the last video, and the 3 principles of data security as well. Encryption is a technique that can address all these problems. Now, as said before, encryption is probably the most fundamental element of secure computing. It's a means to maintain the security of the data in the open world of the internet or the web. However, it's important to note that it's only a single element in the whole system. A system is only as secure as its weakest link. So regardless of how good your encryption is, if something else in this system is open or vulnerable, then the encryption doesn't mean anything, or might not mean anything.